Hello everyone, welcome to the first module of Data Analysis with Python full course. This is Sumit Shukla, Senior Data Scientist and an educator. In this particular module, we'll be talking about how to perform data analysis with Pandas and some complex functions. So let's get started. So let's now start learning about some complex function in Pandas. Now I have already covered the basics of Python and the basics of Pandas in another video for which you can find out the link in the description box, and I would recommend all of you to complete those videos before you start this particular one, because here we will be talking about more complex functions. So let's get started. Now as you guys already know that if I want to use Pandas, I need to first of all import the Pandas library. So let's import Pandas as PD. So we have imported the Pandas library. Now in order to perform any kind of data analysis, we first of all need data, right? So let's import data. So pd dot read underscore csv, and I have already uploaded my data in this external repository known as data.word. So we'll be directly reading the data from this particular external repository. Now there is also a particular option to upload your data in this particular Google Colab, and then you can call that particular data into your data frame. That is one option which is always available. You can also mount your drive if you want to read your data directly from drive. But this option is something which I find convenient, but it is completely up to you which method you want to follow. So let's read this particular data and let's try to understand what this data is all about. So this data is having the details of various customers and their attribute that defines the customer. So we have customer ID, the gender of the customer, whether the customer is a senior citizen or not, whether the customer is having partner or not, and all other details. And then we have details like what is the contract, basically at what frequency the customer is paying the bill, so month to month, 1 year, 2 year. What are the various payment methods? So is it mailed check, or is it electronic check, or it is bank transfer? Then we have total charges, we have monthly charges, and finally we have the column churn. Now churn is equal to no means the customer is currently active in the network. Churn is equal to yes means the customer has left the company. So this is a very general English term. If I say that the employee has churned or the customer has churned, that basically means the customer has or the employee has left the company or left the service. So that is what the particular column churn in this particular data defines. Now the very first topic that we are going to understand is how to perform multi-level filter. So let's say I need to filter my data on one particular attribute, which is gender. So we will first of all take the gender column and then we will equate it to the particular value with which I want to filter. So is equal to, if you want to perform equality check, please remember we use double is equal to, and then we equate it to the category male. Now 1 is equal to basically means we are assigning, double is equal to basically means we are checking the equality. So wherever this gender column is equal to the male column, we will get the binary output, a series which is a binary series. So here you can see we have a binary series, and this is having true and false. The particular value true in this particular series defines that at index position number 1, the gender column is having the value male. Similarly, at index position number 4, the gender column is having the value female. But how to get the data? How to get the filtered data? So we will just simply say df square brackets. Now please remember these square brackets are used for indexing and slicing. So if I have to index my data, if I have to filter my data, if I have to slice my data, we use these square brackets. And then I will pass this particular condition within this square bracket. So wherever I am having a false, I will not get that particular row. Wherever I'm having a true, that particular row will be returned to us. So if I run this, you can see that I do not have row number 0 in my output. Similarly, I do not have row number 4 because row number 4 is having false. So here also you can see we are having 3, but then we are having 6. We do not have 4 and 5 because those rows are having false. Now this is how you can perform single filter. But how to perform multiple filter, or how to perform filter on multiple conditions? Let's understand that with an example. So let's say I'm having one particular data which is having attributes like customer ID, gender, and let's say age. And then we have one more column, churn. Churn can have yes or no. Gender can have male or female, and age can be a numerical value within some range. Now, suppose that we have assigned the label or the variable to this particular data as df. So if I say df square bracket, then the first condition, df gender is equal to male. Then for and we use the ampersand, for or we use the pipe operator. So and df age is, let's say, greater than 18, then and df churn is equal to, let's say, yes. Now if we closely observe what kind of data we will get given this particular code and given this particular condition, we will get those customers who are male, their age is greater than 18, and they are churned. So churn is equal to yes. I'll get these customers. Now if you look into the general pattern of how we have written the code, we have the variable data frame, then we have these square brackets for indexing and slicing, and then within these square brackets I'm having condition 1, then and or, condition 2, then and or, condition 3, and so on. Now please remember, these conditions are needed to be separated by these round brackets. These are very important. So this is the general schema of how we write multi-filter in Pandas. Let's try to test it. So now let's say I have to filter my data on gender and on tenure and churn. So I have to write 3 conditions. So df, the very first condition in first round bracket, df gender is equal to male, and df tenure is, let's say, greater than 20 months. Then and the final condition, df churn is equal to no. Let's say this is my data. Now here you can see that I have got the filtered data. Now how to perform the analysis on this filtered data? Well, consider this as a new data frame. So consider this complete code as df. Let me go back to my slide. So what I mean to say is, if this is my code df condition 1 and condition 2 and condition 3, then consider this complete code as df. Now if I have to index any column from this filtered data, I'll just need to add a square bracket after this, which basically means if I add a square bracket after this, and let's say I have to extract the column monthly charges, then I can do simply like this. This is one way in which you can write the code in the single, or you can write the complete logic in the single line of code. That's one way. Another way is you can assign this output to a variable df or df1, and then you just do the same thing. So df1 square bracket, then monthly charges. Now please remember one thing, if I write the complete logic in one line of code, the advantage is we are not creating unnecessary variables, which is eventually going to eat up your memory, and it will be more cluttered, and it will be really difficult for you to manage all the variables. So I will always suggest you, until and unless you do not need an additional variable, don't create it, and try to write your complete logic within one line of code. Okay, so I hope you guys are clear with how to write multi-level filter. Now what we are going to do in this video as we move forward, we'll be looking at more and more complex mechanism or complex functions with which we can work in Pandas. One such one such technique which we have seen already is how to apply multi-filters. Now let's talk about a very important function known as unique and NUnique. That particular function is a very simple function but very useful in variety of cases. Let's try to understand the case and the function. Now let's say we have this data. Now given this data, I do not know, given a particular column, how many unique values or how many distinct values I'm having in a particular column. And sometimes you might need to get the idea regarding how many unique or distinct categories or values you have in a column, right? Maybe it may be for filter purpose, it may be for any objective, but you might have to get idea about how many distinct values you have in a particular column, right? So let's say I need to find out what are the various distinct values I have in the column payment method. I'll just simply say df payment method, and then the particular function is this is not a function, this is known as the attribute, because it is the part of the Pandas framework. So the particular attribute is NUnique. Now it will return you the count, how many distinct values you have in the column payment method. We have 4, but what if I need to find out those values? What are those distinct values? I'll just use the attribute unique, and then the answer is we have electronic check, mailed check, bank transfer, credit card. Now what if I also need their count? What is the count, or how many rows I am having for electronic check, how many I'm having for mailed check, how many for bank transfer, how many for credit card? Then in that case we have a function, the attribute known as value counts. Very important, very useful. You do not have to apply group by, just say payment method dot value underscore counts, and here you have the answer. Now again, one more question. What if I want to look at the percentage? Now one way to get the percentage is divide this complete series by the total number of rows. How to get total number of rows? df dot shape, and shape is an attribute. So we have 7043, but I only need the number of rows, so we will index this tuple. This is my output as tuple. I'll index it, square bracket 0. So this is 7043. Now what I'll do, I'll take this code and I'll divide it with df.shape square bracket 0. That would give me the ratio, but I need a percentage. So I'll multiply this series with 100. Now if you want to avoid all these unnecessary steps, your value count function inherently comes with a particular parameter known as normalize. Normalize is equal to true, and we are done. Now if you want to avoid all these unnecessary functions and all these unnecessary code, your value count function comes with a very important or a very useful parameter known as normalize. Normalize is equal to true. This will basically return you the ratio. You can see we have the ratio, and if I simply multiply it with 100, I am done. I now have the percentage. Now you can see that these are very simple functions, unique and NUnique, value counts, but they are very useful when you are performing data analysis, because when you perform data analysis, you sometimes needs to understand if there is a given column and it is having a lot of values, then what is the number of unique values you have in that column, right? And sometimes you also need to find out what is the proportion of each unique value in your column. So these functions comes very handy, right? So let's now try to understand about more complex functions. So let's now understand how to group the data. If I'm interested in grouping my data, let's say I'm having the data which looks like this. We have customer ID, we have the gender, we have, let's say, the tenure, and finally we have churn. And now we want to group the data on gender to find out average tenure. So group the data on gender to find the average tenure. Now this is what we have to do. So we will simply write df dot group by, on which column I need to group, on gender, then dot aggregate, on which column I need to aggregate, I need to aggregate on the tenure column, and then what aggregation function you want to apply. So I want to aggregate on the tenure column, and then what aggregation function you want to apply. So I want to apply the average, so I'll write mean, and this is my complete code. Now if you carefully observe, this code is having two subsections or two sections. Number one is, this is my target data frame, this is my group by command. So basically on which column you want to group, so on which column we want to group. Then once we have grouped the data, then how you want to aggregate the data. So grouping is done. Let's try to visualize it. So let's say I'm having some 4 rows. I'll just quickly create a dummy data just to help you understand the process. So 0, 1, 2, 3, gender is male, 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 female, and I should not write it in a grouped format. So gender is male, female, female, male. Then tenure is, let's say, 5, 10, 10, 5. And churn is no, 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 and yes. Let's say this is my data. Now we will have to group the data on gender column. So what will happen? I'll get the output like this. Gender will become the index of my data frame. So here I will have male, male, female, female. Then I'll have customer ID, which is 0312. Then I will have tenure. This will be 5, 5, 10, 10. And the final column is John. This will be no, yes, no, no. This is now the index of the data frame. Gender column has become the index of the data frame. This stage is known as the grouping stage, where I have applied the GroupBy function. So here we have applied the GroupBy function on the gender column. Now this is my data frame TF. Please remember that this is my intermediate output, which will not be displayed to you until and unless you aggregate. So this is my intermediate output, which is available in the internal memory but not visible to the user. So not visible to the user. Now it will only be visible to the user once you aggregate. So I will aggregate. Now, in which column I need to aggregate? I need to aggregate on the tenure column. Please remember, here you can carefully observe we have a dictionary. Here we have a dictionary. This dictionary is having the key as the column name on which you want to perform the aggregation. Then value is the function or the aggregation function. And this particular dictionary is a part of the aggregate function. So AGG is my aggregate function, right? So what will happen in the aggregation stage? I will get the output like this, where I'm having male, female, and against male I'm having average of tenure. So average of tenure will be 5 plus 5, this is 10 divided by 2, again 5, and this will be 10, and this will be my output, which will be visible to us, right? So this is how we group the data. Let's quickly look into one example. So df.groupBy, I want to group on the gender column and then aggregate on the tenure column, and we want to use the average tenure. Here we have the result, right? You can see gender is male, female. We have the average tenure. How to perform multi-level grouping? What if I need to group the data on gender and the churn column? No problem. So in the GroupBy function, instead of passing the column name, we pass the list of column names. So here we have a list, and then within that we pass the column name. The level 1 group is gender, level 2 group is churn, and then aggregate on. You can aggregate on any number of column you want. So first aggregation is on the tenure column, where I want mean. The second aggregate is on the customer ID column. The second aggregate is on the customer ID column where I have to count. So let's run this. Okay, I think the churn column has to have the capital C, and then the customer ID column. So let me just quickly check. Small c and capital D. So small c and capital D. And here you can see we have the multi-level group result. So first we have grouped the data on gender, male and female. Then within female and male, we have churn is equal to no and yes. Now, if you carefully read this result, it becomes difficult for a reader or for a person who is analyzing or reading your result to better understand this, right? Now there can be multiple reasons, and there can be two schools of thought. Some of you may be thinking that this is the best result which you can read. Some of you may be facing a problem in reading this result. There is an option known as pivot table, which is very similar to the Excel pivot table, which can help you to perform aggregation on both rows and columns. As of now, using GroupBy, we can only aggregate the data on we can only aggregate the data on row levels, not on the column level. Let's first of all look into the one group, which we will then convert into a pivot table. So let's say we are grouping it on let's say contract and churn, and then we are aggregating it on, let's say, the count, or let's say monthly charges. We are taking the average, so mean. Okay, we haven't closed the bracket over here, so let's close the bracket. Okay, something is still wrong. There is one extra bracket. So here we have the result. We have contract group by level, we have the churn group by level, and then we have the average monthly charges. Again, difficult to read according to me. Let's try to transform it into a pivot table. So let's first of all understand the concept of pivot table. Now we have seen this result, right? We were having the two group columns and then one aggregation column. So how the result was visible to us? We were having the contract level, the churn level, and then this the average monthly charges. So contract was let's say month to month. Then we are having within month to month, we have yes, no. Then we are having 2 year. So then we are within this, I'm having yes and no. And then we finally have 1 year. Then we are having yes and no within it. And then we were having some values. So there was some value over here, 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 and here. But I want to transform this now into a matrix which looks like this. So on the row, I'm having yes and no, and on the column, I'm having month to month, 2 year, and finally 1 year. Let's say this is what I want to achieve. So let's say the values were A, B, C, D, E, F. Now the values are A, C, E, B, D, F. Let's say this is what I want to create. So using GroupBy, we have created this output. So using group by, we can perform grouping on only row level. So we can only group the data on row level, but using pivot table, we can perform grouping on both rows and columns. So can group the data on both row and column level. So how we perform pivot table, or how to generate a pivot table? Number one, df dot pivot underscore table. This is the very first thing. Then we have to define what you want to keep on your index. So index, now index is nothing but this. These are known as my index, and as of now I have kept the churn column on my index. So I'll write, and on the index I want the column churn. This is known as my columns. So what I have kept on my columns? The contract column. So columns is equal to contract. Then using which column you have filled this table. So I have taken the average of monthly charges. So monthly charges is the column, or this is known as the values. So values, the values are monthly charges. And finally we have the attribute, which is aggregation function. So aggfunc, which is nothing but my mean, and we close the bracket. So pivot table takes 4 input. Number one, index. So what you want to keep on your rows, the row column. Then we have columns, what you want to keep on your column level. So column level. Then values, with which column we need to fill the table. And finally aggregation function, at or using what aggregation method you want to summarize the table. So function using which we summarize the table. This is what the pivot table function is. Now let's try to apply it in the data frame. So let's try to convert this row aggregated table into a pivot table. df dot pivot underscore table. On the index I want to keep the column churn. Now there is no such limitation that you should only keep churn or you should only keep contract on the index level. It is up to you how you want your table to look like. If I keep contract, I will have 3 values on my row. If I keep churn, I will have 2 values on my row. So just to make sure I'm getting a rectangle which is horizontally visible, I'm keeping churn on my rows. So index is equal to churn, columns is equal to contract, then we have values is equal to monthly charges, and finally we have aggregation function. Aggregation function is, as of now, it is mean, and let's execute this one. Okay, there is some problem. Okay, I have used 2 is equal to. So here you can see we have the same result but visible in a very clean matrix like pivot format, which is easy to read and easy to explain, right? So this is how we can group the data. We have seen both the examples, how to group the data on using GroupBy functionalities, and within GroupBy how to perform one level grouping or multi-level grouping. Then we have seen the example of how to use pivot tables to group the data on both row and column level. Now let's talk about how to delete a column and how to add a new column in a Pandas data frame. First, let's talk about how to delete a column. In order to delete a column, we have a function which is known as drop. And using drop, I can drop either a row or a column. So if I say df.drop, the drop function takes input as the name of the column or the index number of the row you want to drop. Let's say I want to drop the column as let's say customer ID, and I just have to write df.drop columns is equal to customer ID. Now please remember one thing. This particular function will return you a new data frame with that operation applied. What was the operation? To drop the customer ID column. So using drop function, it will return me a new data frame. So this is a particular new data frame in which this operation has been applied, but this operation is not applied to my core data frame or the parent data frame. So this df is still having customer ID column. If you want to get this operation applied permanently on the parent data frame also, then we have a particular parameter known as inPlace is equal to true. Now before you use this function, please remain very much sure that you want to drop this particular column from your data frame, because you cannot reverse back this operation. Once you drop a column, you cannot reverse this operation. You have to again go back, again import your data and again perform all the operations that you have done. So please be very much cautioned before using inPlace is equal to true. I'm not going to use it as of now. I'm just leaving it as a commented code, but if you want to use it, you may use it. So I'll just copy this much portion, df.drop column is equal to customer ID. What if I want to drop a particular row? Well, in that case, I have the option known as df.drop index is equal to the index number of the row that you want to drop. So index will take the index number of the row that you want to drop. So I want to drop row number, let's say 2. So I'll just simply say drop 2 and it will drop row number 2. You will get a new data frame with that operation applied. So I'm having row number 0, I'm having row number 1, but I do not have row number 2. Directly have row number 3. Can we drop row and column simultaneously? Yes, you can. df.drop columns is equal to customer ID, then comma, index is equal to 2. And now this operation or this new data frame, you can see we do not have the customer ID column, I do not have the row number 2. So simultaneously we have dropped row and column. Now can I drop multiple columns? Yes, you can. So let me just quickly copy this. And in order to drop multiple columns, instead of just the column name, I'll provide list of column names. Let's say I also want to drop the column churn. And here if I scroll towards the end, you can see we do not have the churn column. And I do not have the first column, which was customer ID, right? So this is how you can drop the column. Now df.drop function comes with one more traditional way in which you can drop a row or a column, or simultaneously both. Before the introduction of the parameters like columns and index, there was a parameter known as axis. So if you just want to drop a particular column, I can simply say df.drop the name of the column. Let's say I want to drop customer ID, and then I have to indicate, I have to declare the drop function that this particular value, whether this value belongs to the column headers or the row index. Since it is a column, I would say axis is equal to 1, and then this will work as a function to drop a column. Here you can see we are able to drop a column. Now this axis parameter is really important. Axis is equal to 1 means I am doing something with my columns. Axis is equal to 0 means I am doing something with my rows. So if I just quickly copy this function, put it over here, instead of customer ID, if I write 2, and axis will now be becoming 0, then this will be working as a function to drop a row. And here you can see I do not have row number 2. So this is how we can drop a particular column or a particular row, or maybe both of them together. Now let's try to understand how to add a new column. In order to add a new column, so let's say this is my head of the data frame, and I want to create a new column which is half the tenure. So my new column df, the name of that new column is tenure underscore half, and this will have the value of tenure column but divided by 2. Now this is one way in which you can add a new column. If I quickly look, I will have a new column tenure half, right? So this is the general, you can say, code schema. The new column which we are assigning with this particular series, and this series is nothing but the half of my tenure column, right? Let's say I want to create a new column based on some existing column, and over the existing column I have applied some condition. So let's try to create that. First of all, in order to get some condition drafted, I need to quickly find out what is my minimum tenure and what is my maximum tenure. So my minimum tenure is 0, maximum tenure is 72. Now let's understand how to create the conditions. So first of all, we will create a function. Let's say function named as tenure underscore bucket, tenure underscore b. Then this function will have conditions like if let's say the input is a. If a is greater than 5, then I want to return, let's say I want to return the value as d. If the value is greater than or equal to 5 and the value is less than, let's say 20, then I want to return c. Then elif the value is greater than or equal to 20 and value is less than, let's say 50, then return d, or maybe b. Then elif a is greater than or equal to 50 and a is less than, let's say 60, then return, or let's say a is greater than or equal to 50 is my last condition, so I'll just simply say else return A. Now this is my function. If I want to create or if I want to apply this function to an existing column, I'll just say df the column name, which is tenure dot apply this function tenure underscore b. Now it will generate a new series which will have values such as a, b, c, d. If I want to assign it to a new column, I can do something like this. So let's say tenure underscore or hyphen b, and this is my new column which is created based on a condition. Let's try to quickly apply this or maybe code this in Python. So let's first of all create the function def t underscore b. This function will take the input x. Now if my x is less than 5, then return let's say return d. Then elif x is greater than or equal to 5 and x is less than, let's say 20, then return, let's say c. Then elif x is greater than or equal to 20 and x is less than, let's say 50, or yes 50, then return b. Finally we write the else block, else return a. We have this function. Now we apply this function on the tenure column. So tenure dot apply, I want to apply the t underscore b function. We have the series. I want to assign this series to a new column which is df tenure underscore b, and here we have the new column tenure underscore b. Now there is one problem, and you guys would have learnt about this already, that when we create a defined function, it consumes memory, it gets preserved in our memory, and I do not need this function for next usage. I only need this function for one time. Once we have generated this new column, I do not need this. So the better way is to write the lambda function, right? So let's do it using lambda function. Tenure underscore b is equal to df tenure dot apply. Now lambda function is written with the keywords lambda, then input is x, then what output you need? I need d. I need the output d if x is less than 5. Else I'll create another code block. I need the output c if x is greater than or equal to 5 and x is less than 20. Else I'll create another code block. I need the output to be b if x is greater than or equal to 20 and x is less than 50. Else I need a, and this is done. Let's not assign it to any variable. Let's only look at the output, and here you can see we have the same output. So it is always instructed or maybe suggested to all of you that if you are creating a new column based on certain condition on the existing column, always try to use the lambda function so that you are not wasting your memory. It is one time usage function. We have used it. Now this is not getting preserved anywhere in our memory, and we have also created this new series which I can preserve in a new column or existing column, and then we have that particular column in our data frame. Now this was all about this particular video. I hope we have covered up some good complex functions like how to apply single filter, multiple filter. Then we talked about the very small, very less known functions like NUnique, unique, value count, and then how to use the parameter normalize in the value count function. Then we talked about how to use GroupBy. Within GroupBy, how to apply multiple level grouping. Then we talked about pivot tables, and then we talked about the drop function, how to use columns, how to use index, then how to use axis, and finally we learned about how to create a new column based on some conditions and the usage of lambda function. I hope this module was informative and really useful for all of you. If you like this video, give it a big thumbs up, share it with your friends, and don't forget to subscribe to our Scalers YouTube channel.